Hello, academic stars around the world. Welcome to Caltex Academy. Yes, my name is Julius, and thank you for coming around. Today on our board, we are looking at trigonometric questions and specifically on Cartesian plane. So if you have not watched the previous video, I strongly advise you to first watch that video. The link is in the description of our video here, or you can also check out the card up here and first watch that video because we explain hash diagram into detail before you continue. So in this video, I prepared for you 4 questions and stick around at the end because the last question is very interesting. So let's dive into the video. In question number 1, we have point P with coordinates of -3 and 4 is a point on the Cartesian plane with origin O. And I've prepared something here for us that is our Cartesian plane with X and Y. So if this is the origin O, theta is the angle between OP. So our point is here with the coordinates of -3 and 4. So O is here, and that is our angle theta, like that. Now from here, this -3 is here, the distance from here up to there, and that is the adjacent. And we have 4 is opposite, and that is 4 here. Now we don't know the hypotenuse, and always in Cartesian plane we represent it with letter R. So firstly, we need to get that hypotenuse because sine and cosine uses hypotenuse. So let's go ahead and do it right away here. And R square equals X square plus Y square. Now let's make substitution. R square equals X is negative, so we place it in bracket, and we have -3 square plus Y is 4, and we also square that. Therefore, we have here 9 plus 16, and the sum of these two numbers is 25. So getting root on both sides, we have square root of 25 is 5, and square root of R square is R. So we have 5 units as the value for R here. Now, since we know our hypotenuse, we can go ahead and start answering this, but I need to first list them basically here, and we have sine of this angle theta is given by always opposite. For our case here, the opposite is 4 over hypotenuse. We have here 5. Now let's move on to cos of the same angle theta is given by adjacent, and our adjacent is -3 over hypotenuse, also 5. And finally, we have tan of an angle theta is given by opposite, that is 4 over adjacent, and that is -3. We had these 3 things here. We are seeing cos, tan, and sine. Cos is repeated. Whenever we get this, we just make some substitution. So part A is asking us to get cosine of theta. So for that case, it's exactly what we have here. We can transfer down here, and we have -3 over 5. Part A of the question is done. So let's move on to part B, and that is 3 tan of the angle theta. So this is equivalent to, we are multiplying 3 by the ratio tan theta. And we know from what we have stated here, our tan is 4 over 3. Now you can see this 3 will reduce the denominator to 1. And 4 divided by -1 is -4. And that becomes our answer. So let's move on again and answer part C of the question, which says sine square theta. We can remove this square out and write it as sine theta square. Let us go on and make our substitution here, and we have sine theta is 4 over 5. So we can square. And when we are squaring a fractional number, we can distribute this exponent to the numerator, that is 4 square, and also to the denominator, and that is 5 square. So doing that, square of 4 is 16, and the square of 5 is 25. So that is the solution for part C of the question. So lastly, part D of the question is saying 4 cos cube theta. Again, we can rewrite as the same like what I've done in question C, such that we have 4 into cos of the angle theta, and we pull out this exponent. Then we can make our substitution of cosine of theta, which is adjacent, and negative 3 is our adjacent over hypotenuse 5. Now it is to the power of 3. Now doing the same like what we've just done here, we'll have our 4 still hanging around here, and distributing this exponent 3 to these numbers. Maybe let me create another bracket inside here, because this is a negative number, such that we have here our negative 3 is raised to the power of 3, and we're dividing it by 5, again raised to the power 3, and this is from distributive law. So this bracket here means we're gonna multiply the result by 4 after simplifying what is inside the bracket. So let's move on and first simplify. Now, when we cube negative 3, we get negative 27. Keep in mind that odd powers are always giving us negative, and even powers give us positive. Even if you don't press your calculator, you can still get your answer following that technique. Lastly, we have to open up this bracket by multiplying through, and 4 times 7 is 28. We can write 8 and add 2. 4 times 2 is 8 plus 2 is 10. So we have here negative 108 over 125. So this is how we solve question number 1. If this video interests you, please go ahead and give this video a thumbs up, subscribe to the channel to show your gratitude to this channel, and let us move on to question number 2. For question number 2, we are given that if sine theta is equals to 0.4 and theta is an obtuse angle, determine cos theta and root 21 times tan theta. We are given a range in which our angle theta lies. Remember, in our previous video, we talked about trigonometry. Ratios always deals with acute angle, so we have to locate the acute angle in a right quadrant. So acute angle is something that looks like this. Would be in first quadrant, second quadrant, third quadrant, or fourth. Now, since it is sine, and here is positive, then sine is always positive in the first quadrant and the second quadrant. And an obtuse angle is greater than 90 degrees. Therefore, this angle definitely lies in the second quadrant. So let's go ahead and have a drawing. Okay, so let's locate again this one here. Now we have to draw also perpendicular to this line here, and so that is a right angle by indicating the angle here. So after that, we need to also show our angle here, and the question is using theta, so we also use the same thing here, theta, and that is our angle. Now, since we have here 0.4 is always a divisible to first convert this one here to fractional because sine is opposite over hypotenuse. And to be able to come up with the numerator and denominator, the easiest way is just to get your calculator and you enter this 0.4 in your calc and will give you 2 over 5. So from here you say sine of angle theta here has been given the same as 0.4. So in other words, our sine theta is equals to 5. Now from the definition of sine, we know that sine is opposite, and according to this diagram, we have here opposite as 2 and hypotenuse is 5. Now before we proceed on, this is x-axis and we have here y-axis. So from here, what is left is the value for x down here. And since we have cos, then we first need to get this value for x because it deals with adjacent and hypotenuse for cos, and also tan deals with opposite and adjacent. So it's important for us to get this. Now let's go on and use Pythagoras theorem again to get that value. So from here we have our square is given by our value for x square plus the value of y square. And x is what we're looking for, so r is 5. Now x square plus y is 2 square. So for ultimate terms, we can simplify this to 25, and this will be minus 4. This is equivalent to x square. Now subtracting 4 away from 25, we get 21 equals x square. We'll arrange this and let's also get more space. We'll have our x square equals 21. And we're getting square root on all the sides. But remember, the square root of a number is always positive or negative. Now for this letter, the square root is x. And since we're in the second quadrant, then the value for x here is negative. So we can leave it in the third form and have 21, since 21 is not a square number. And also given part B of the question, we have something similar like what I've just gotten here, that is under root of 21. So let's start answering our question right away. So part A of the question is asking us to get cos of the angle theta. This is given by adjacent over hypotenuse. So our adjacent is negative root 21. So let's go ahead and negative 21 over hypotenuse is 5. And that is the solution for part A of the question. So let's move on to part B and have root 21 tan theta. So we have here root 21 tan is given by adjust is given by opposite, and our opposite is 2 over adjacent negative root 21. So here we can see that this 21 and the square root will go with what we have here to 1. And 1 times 2 is 2, divided by negative 1 is the same as negative 2. So the solution for our second part is negative 2. And that is all question number 2. I think the video is interesting and we are learning something. If you have some question, please don't hesitate to drop it in the comment section. I will put time to answer you as soon as possible. So let's move on to question number 3. Alright, question number 3 is right away here. And it says, given that tan theta is equals to 1 over 2. Oops, this one moves a little bit slightly somewhere. This is an over. So where theta degrees is less than or equals to theta is less than or equals to 90 degrees, determine the following in terms of t. The first one is cos square theta, and secondly, try sine cube theta. And here, this one is a range in which we can locate our angle theta, and that angle, of course, is the acute angle. So before you proceed ahead, we first need to draw this angle here to be able to locate exactly where it lies. According to the guide, it is in the first quadrant. So let's move on and select our axis, and we have it here. So more of this space will be given to the first quadrant, and we have it like that. Then we can get our line that we can use for locating the angle with the horizontal. I think this is big enough. Again, let us draw the perpendicular here from this point. I think this one looks fair. Now we can show that the right angle is exactly here. So we do that like that. Okay, so let's show the angle theta from the diagram, and that is our angle theta. And the next with the horizontal axis here, which is x-axis, and this is our y-axis. So according to what we have here, we have tan of our angle theta is given by t over 2. So from the definition of tan is given by opposite over adjacent. So our opposite according to this diagram here is t, then adjacent is 2. So we are missing r. Now again, let's go ahead and find the value for r from here, and that is the same as r square equals x square plus y square. And this is from Pythagoras theorem. Therefore, x is 2 square and y is t square. So we can move on and square 2 to 4, and here we have t square. Getting it on all the sides and knowing that we are looking for hypotenuse. Hypotenuse is always positive, so simply write it without the positive or negative, because we definitely know this is going to be positive. So we have here root of 4 plus t square. Now after that, we can now go ahead and start answering our question here. Part A, saying cos square theta, we can write it as cos inside the bracket, then we square. Now putting in our cos theta according to definition as adjacent over hypotenuse. Our adjacent is 2, and the hypotenuse is what we've just gotten here, and that is 4 plus t square. So the whole thing should be squared because our cos here was squared. Let's distribute this exponent to the two numbers. Definitely the numerator will go to 4, and this square will have to cross with our square root, taking into account if you have a number raised power a half and again to another square, these exponents will multiply themselves, and you have a to the exponent of 1/2 times 2, and the 2 will cancel with this, leaving it to the exponent of 1, and anything to power 1 is itself. So the square root is the same as the 1/2. Therefore, the square root sign will disappear from the denominator, and we have only 4 plus t square, and that becomes the solution for part A of this question. Again, let's go ahead and work out part B, which says we need 2 sine cube theta. So let's do that down here, and we have part B as 2 sine cube theta. This is the same as we first need to rewrite, and we create a bracket saying sine theta is raised to the power of 3. Now, from where sine is given by opposite over hypotenuse. So from our diagram here, our opposite is t and hypotenuse is this term which looks a little bit bulky. So we have t over under square root of 4 plus t square. Now the whole thing is to the power of 3. So let's move on and distribute the power again, but still maintaining our 2 outside here, and the numerator goes to t exponent 3. Meanwhile, the denominator goes to 4 plus t square. We can create a bracket here, and 1 half as a power, we multiply this 3, is a half here, 3 over 2. Again, if you leave it in this form, where you bring in our 1 over 3 to be a power in the denominator, is also accepted. So let's open up this bracket by multiplying this by 2. Remember, this one multiplies the numerator. So we have twice t cubed all over in bracket 4 plus t square, and this is raised to the power of 3 over 2. That is the solution for part B of our question. And I think question number 3 is done. So still after now, if you have not subscribed, do for me some small favor to appreciate my work by subscribing to the channel. It's for free. So let's move on to our last question, and that is question number 4. Yep, in this question it says, given that 10 cos beta plus 8 equals 0 in a range of 180 degrees is less than or equals to beta and is less than or equals to 360. So this range here tells us that the acute angle for this question should lie in the third quadrant and the fourth quadrant. So what do we do when we have this kind of question? We have to simplify such that we have this one as one angle. So that is the first step we have to mark here. Now, let's go ahead and do that. We first need to copy our given expression here, that we have 10 cos of beta. We add our 8. This must give us 0. So taking this to the other side, we have still our 10 attached to cos of beta, and this must give us negative 8. So from there, we need to remove this coefficient of cos beta by dividing everything by 10. So we're left here with cos beta is the same as negative 8 all over 10. And from here, this represents the adjacent, and now since the cosine is negative, and we know that from our class diagram, we normally say all students take coffee. And the range here is telling us that we are in the third quadrant and the fourth quadrant. So where is cos negative between the two quadrants? Definitely cos is positive in the fourth quadrant, and since our result here is negative, then it must be in the third quadrant. Now let's draw it in a proper way by making it somewhere here. So let's pick our axis here, and our main focus is on the third quadrant, so we give enough space in the third quadrant than any of these quadrants. Then we can take our line that is for R somewhere here. We also need to draw a perpendicular to make this angle theta here at 90. So let's do that, make it 90. Therefore, we can also rename our angle here as beta, as the question suggested. So looking at what I've just given here, this is negative 8 as adjacent, and it's here exactly as we got it for x over hypotenuse, that is 10. And since we have sine and tan, then we need this opposite to the angle beta. Again, this still take us back to using Pythagoras theorem. Therefore, r square is equivalent to, this time I'm substituting directly, x value is negative a, and that is squared, plus y value is what we're looking for, and we say y squared. Instead of saying r squared, let's get our eraser and move it out such that we replace this one here by 10. Moving on, we have here 10 square, and that is 100. So this must be equivalent to 64 plus y square. I need to rearrange everything, bringing my y this side, and we have here 100 minus 64. What I've just done here is to take 64 to the left hand side and swap everything around. So when you subtract that 64 away from 100, we simply get 36. And we get square root. Remember, is positive and negative here. Therefore, our y is equivalent to, we need to see which one is the valid results. Since it is down this way, then this must be a negative 6. So we have here our valid answer is negative 6. But before that, we first need to write there positive and negative. Then we conclude later that y value should be negative 6 units. So transferring it up there and pasting it on our diagram, we have negative 6 here. For consistency, let's have the same color here. We can move on and start answering the question. Problem number 1 is being answered here already. You just need to transfer it down here and say cos of beta is the same as adjacent, which is 8 over hypotenuse 10. And that is the solution. Then problem number 2 is 3 all over tan of our angle beta, and we add it to twice sine, and this sine here is squared of the same angle beta. So let's go ahead and make substitution according to our formula here. Now create some equal sign around here, and we have 3. So tan is opposite of adjacent. So our opposite is negative 6 over adjacent is also negative a. So it's good to have this in bracket, and we add these two twice, and in bracket sine of beta is given by opposite over hypotenuse. Our opposite is negative 6 over hypotenuse is 10. And sine is squared, so we can bring our square outside here. So let's go ahead and make simplification to this. So you see that these negatives will cancel, and we also reduce this down by 3 to 2, by 2 to 3, because this 8 divides 2 to 4. What we have here, the first term is 3 all over 3 over 4. And the next one here is 2 multiplies, I think I can also reduce this down to, let's say, by 2 to 3 and by 2 to 5. Now rewriting this, we have negative 3, and distributing also this power, we have square all over 5. Also distributing the square, we have 5 square. The first term here is the same as 3. We can take this 4 up to multiply, and we divide it by 3. So we add this 2, reducing up this inside bracket. The square of negative 3 is 9, and the square of 5 is 25. Since 2 cannot divide 25, we can just multiply the numerators. Now again, here it is easy that the 3 will have to reduce down 1. If you have not reorganized, you just multiply 3 and 4, make 12, and 12 divided by 3, you get still 4. So let's move on and have our 4 written here. Now we add this one to 18 over 25. And here you can go ahead to use a calculator to work this out, or if you don't have a calculator, you can put this over 1 and make sure that the denominator here has the same number just like what we have here. And it's easier than the thing for us to get also 25 here. In maths, we are allowed to multiply by the same number, 25, and the numerator also by 25, or dividing by the same number is always allowed. So doing that, when you multiply the numerator, we get 100, and denominator, we get 25. So we copy our second term, and that is 18 all over 25. Since the denominators are all the same, then what we can do is to add the numerators and take it over a common denominator, 25. So when you add 100 plus 18, you get 118 all over 25. And that is all for this video. If you have watched after this time, thank you very much for supporting me through watching this video, and see you in the next one. Peace out.